Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are still going to continue talking about combustion. Previously, we discussed on methods of preparing oxygen, and we said that oxygen can be preparing by decomposing hydrogen peroxide, reacting sodium peroxide with water, decomposing potassium permanganate 7, and decomposing potassium chlorate. So today we are going to look at properties of oxygen, and specifically the chemical properties of oxygen, that is burning substances in air. So we will look at burning metals in air, which we are going also to take in the next session. So the substances that we are going to talk about today are metals, and when substances burn, they react mainly with oxygen. We talked about oxygen being the active part of air, as we were discussing in the beginning of the topic. And oxygen is a very reactive non-metal, and many elements usually react with oxygen, and they form compounds referred to as oxides. This involves both metals and also non-metals. So when oxygen combines with these elements, we can refer to that as combustion or burning. So if you hear that word combustion, it's just the reaction of oxygen with elements or different substances. So we are going to look at the reaction of magnesium in air. So magnesium is put in a diffractating spoon, and it's heated slightly and then lowered in a gas jar containing oxygen. So what happens is that in that closed container, most of the air is usually consumed, or magnesium reacts with the most of the oxygen in the container. So some of the observation you notice for this reaction is that magnesium burns with a bright blithering flame. You're going to see that brightness, it's going to be blinding, it's so bright. And after the reaction is complete, a white ash or a powder is formed, or it's left either in the diffractating spoon or in the container that is going to be used, or in the crucible. So those are the two observations that you notice in this reaction. We know that when you burn magnesium, a lot of heat is produced. This a lot of heat enables magnesium to react with both oxygen and nitrogen. So when you look at the components of air, we said nitrogen forms the highest percentage. So when magnesium is burning in air, it is not only burning in air to react with oxygen, as we said in combustion, but because of the heat that is being produced in this reaction, it causes also the reaction of magnesium with nitrogen. So the powder that we are forming is a combination of the reaction of oxygen and of the reaction of nitrogen. So magnesium, if you look at the equation, reacts with oxygen to form magnesium oxide, and magnesium reacts with nitrogen to form magnesium nitride. This reaction happens simultaneously, and that is what we refer to as the white powder. So if you take magnesium oxide, or one of the white powder, you dissolve it in water, it forms a basic solution. That basic solution, we refer to it as magnesium hydroxide. In the same, or additionally, when you take the magnesium nitride and you dissolve it in water, it's going to form magnesium hydroxide, and ammonia gas is going to be given off. So you can see the white powder is both forming a basic solution, and you can see a gas, ammonia gas, is one of the compounds that is being given off in this reaction. So when you look at the mass of magnesium, the one that we were beginning with in the reaction is going to be different from this white powder, what is happening? There is an increase in the mass. Why is the mass increasing? The mass is increasing because you can see the mass of magnesium that has not combined with any other element will not be equal to the mass of magnesium that has combined with both oxygen and nitrogen. So new products are being formed which have combined with oxygen and nitrogen. So the mass increases greatly. This is going to be contrary to when we go to gas non-metals burning in air, and you'll notice there is a difference in how the change of mass occurs. So the same reaction occurs when we react sodium in oxygen. If you lower a defragrating spoon in a gas jar, sodium burns in a yellow flame to form sodium oxide and sodium nitride, which is also a combination. It's a reaction, it produces a lot of heat. So both also sodium can react with both oxygen and nitrogen. And if you dissolve the product, which is sodium oxide and sodium nitride, in water, you're going still to form the same product as we did with magnesium. You're going to form sodium hydroxide and ammonia gas. So let's look at a few questions so that we can be able to stamp what we have discussed. So when magnesium was burnt in air, a solid mixture was formed. On addition of water to the mixture, a gas which turned red moist litmus paper blue was evolved. Explain this observation. So we'll break down this question first of all into different sections. So we'll start with the first part of the statement. When magnesium was burnt in air, a solid mixture was formed. So we are going to identify the solid mixture, which was magnesium oxide and magnesium nitride, because magnesium burns both with oxygen and nitrogen. Next, we are going to look at the addition of the mixture in the water. So when magnesium oxide and magnesium nitride is dissolved in the water, then we are going to form two products. We are going to form a base and a gas. So we will form magnesium hydroxide and ammonia gas. We are told this gas turned moist red litmus blue. A compound that can turn red litmus blue tells us that that compound is basic in nature. So this tells us the only gas that is produced in this reaction is ammonia gas. So this means that ammonia gas is basic in nature. So how do you answer this question? So explain this observation. So you are going to say magnesium burns in air to form magnesium oxide and magnesium nitride, which dissolves in water to form magnesium hydroxide and ammonia gas. Ammonia gas turns red litmus paper blue. And that will conclude your explanation. I hope you have been able to understand these reactions. So we are still going to continue with these reactions for the next session. We are going to look at more substances burning in air. So stay tuned for that. See you in the next session.